Hello. What I'm going to teach you today in this demonstration is how the different sizes of marbles affect in collisions. So we're really focused on collisions. Now, as you know, if you have ever played football or any other type of sport, or even if you ran into things in a house, when you're running and you collide with something smaller than you, it's easy to move it out of the way. But if you run and you collide with something much bigger than you, you know that you have problems or big bruises. So if I were to take two of these marbles and I were to move them at the same speed and then collide them into each other, I think we know which one's going to win, the larger one, as long as they're going the same speed. Because what if I were to change that? So when I have these, if I have two of these here, I'm going to take the medium one because they're a little bit more even. If I were to put one of them on, if I put the large one on the 3 position and the medium one on 3 position, if they're going at the same speed, so they both have the same amount of potential energy, and they will be going the same amount of speed. So if they're doing that, they're both going to collide and bounce back. However, the medium one bounced back a lot. The large one stopped. Let's do it one more time. In fact, the large one just kind of rolled again a little bit. So it transferred a lot of its energy into this one, but they connected right about here. And the large one just rolled over a little bit more, said, okay, I'm done. And the medium one went booming away because it was so much lighter. What if I were to imbalance this a little bit? Because what I want is I want to find an equal collision. So what I can do is I can put the large one at 2 and the medium one I can raise up higher to a higher level. So if I were to put it at 4, so the large one at 2, the medium one at 4, this one has more potential energy. It's up higher. Therefore, when I release it, it'll turn into kinetic energy and hopefully produce more speed. So if I release this, it has more speed, but less mass. The large one has more mass, but less speed. So we want to find a balance where mass and speed can balance each other out and they both bounce backwards. So let's watch. So close. So what happened was they collided. The large one almost went backwards, but then it still had a little bit more and it rolled forward just a quarter of a bit. So let's try the large one at 2 and the medium at 6. So the medium one is all the way at the top of the ramp. The large one is not quite at the bottom. At the bottom, it doesn't have a lot of energy to get to the middle of the ramp. So that's why I've been using 2. So 2 and 6. There we go. We found a lot more equal balance. They collided right about here. The large one rolled back and the medium went back. So when it collided, the large went back a little bit, but the medium went back a lot. And that's a lot to do with the mass because the lighter one will fly a lot more than a large one. It gets pulled down to earth. So what we had there was, in my idea, is we had something that was more equal. We gave the medium one a lot more energy so that it could travel faster. And that speed or acceleration made the difference and helped balance out the mass. And what we learned later in Newton's laws of theories is force equals mass times acceleration. So if I have more mass in one, but I have more acceleration in the other, it can balance out. It's a calculation. In science, we always want to prove the calculations. We always want to prove the data and be able to calculate it. So if I were designing windows and I want to, I want to make a window that is strong enough to withstand a baseball. So if the kids were out in the backyard playing baseball and they threw the baseball against the window, how fast does that baseball have to be going before it breaks the window? And what we have to do is we have to find calculations. So we take the mass of the baseball and we calculate the speed. So we might say, okay, most kids don't throw or might hit the ball at 70 miles per hour. So can we calculate 70 times the mass of the baseball and we need to create a window that's going to withstand that force. So that is kind of how science works with the real world. They need a specific calculation so that they have data. They can't just say, I think it might break or it might not. They have to be sure. And they need an exact calculation. That's what science does. So let's try this experiment again, and let's see if we can calculate a little bit more. Now, we know that the small marble looks a lot smaller than the medium one. Therefore, since it's solid steel, it has less mass. Mass is the matter inside it. So it has a lot less mass, a lot less steel than this one. So if I put them both at 3, they both have the same amount of potential energy, but one has more mass. So if they're both traveling at the same speed, but one has more mass, it should have more force. And it will smash the other one with more power. And as we can see, that is exactly what happened. So they smashed, and the large one kept going forward, but it transferred some of its energy to the small one. So the small one bounced back too. So we had a lot of energy transfer, but they both continued in the same direction. Now, how can we balance out that force? So the small one, since it has less mass, I need to give it more speed. And to do that, I have to work and put that small one up higher. So I have to physically, I know it's so heavy, I have to lift it all the way up to number 6 to give it more energy. The medium one, I'm just going to put down here at the bottom at number 2, and I'm going to let them collide. So the medium one is going to go slower because it has less energy. The small one is going to go faster. So let's see if the acceleration versus the mass balance out. Okay. Let me try it again, but opposite side. So 2 and 6. All right, so pretty close, pretty close. This one kind of wobbled, but not enough. So I need to try this one at 1 and this at 6. There we go. So it took a little bit more speed from the small one because it was so light that this had to be at 6, this one had to be at 1 before it just turned back. Now they didn't bounce back as the same amount of distance because this one is much lighter and it caused less friction when it rolled back. And there's some other variables in that too. But what I was looking for is that they both bounce backwards. They both bounce backwards. So this one, the medium one, was at 1. The small one was all the way at 6. Now, I did the experiments a lot more, and you can go ahead and get the calculations if we practice this more. But what I wanted to really demonstrate to you today was the collision, how mass versus the amount of energy or acceleration plays a difference in the collisions. Okay, thank you very much.